Question number 7, reflect the given polygon across the y-axis and then rotate the new polygon that you get after that reflection 90 degrees. It says 90 degrees. Get over here. Does it say 90? 90 degrees clockwise about the origin. So first of all, let's start with our reflection, right? So I'll just grab the red pen here and put some dots. So when I reflect across the y-axis, right, this thing is going to go across this way. And the reflected points are going to be the same distance across. So this point right here is the same as this point. I'll put a red dot for each of those. Let me color code this. I'll use a green dot here. And that's going to go to +3 and back up to 6. Nice. And this point right here is at -5. So I'm going to go to +5 and then up to, that's super. There we go. Right. So those are our points, and I could sketch that by just connecting these. Oh, I don't want to do that. There we go. And the last one. Super. So there's that shape after the reflection. The next one is it's time for a rotation. We're going to rotate 90 degrees around the origin. So this shape is going to go this way. Now what's nice about the 90-degree rotation is slopes are going to become opposite reciprocals. So if I zoom in here and think about this a little bit, I haven't used purple yet. From the origin to this red point, right, that line right there, you can see that's a slope of up 1/2. Well, if I want to figure out where that's going to go, up 1/2, right, that's 1/2, is going to become a slope of -2. So from here, I could go down 2/1. This point right here, I'll use the red dot. This point right here is the location that this particular point's going to go to. So I'm there's another way to do this too. If I think about this point, this has the coordinates at 1, 2, and this has the coordinates at, I said that wrong. That's completely wrong. What are you trying? This has the coordinates as x is 2, y is 1. This one has the point where x is 1 and y is -2. So we're also going to see this. When you're rotating clockwise, around the origin, it's going to be the case that this transformation, x comma y, is going to get mapped to, the y is going to become what x is, and the x, the opposite of that, is going to become the y. So that notation is something else that we looked at as well, but this right here, this is equivalent to a 90-degree rotation about the origin. So if I look at this next point here, I'll use the blue dot for it. It was at 5. This was at 5, 2. So what am I going to do? I'm going to go over 2 and down 5. So that's where that point's going to land. And the last one's the green point. The green point was over 3, up 6. So I'm going to go over 6 and then down 3. And that's totally consistent with the notation we have there. So this is the shape that we're going to land at when we go ahead and do this rotation 90 degrees about the origin. And I'll just sketch this. Yeah, oh, that's interesting. I don't like that. I feel like it used to not do that to me. There we go. Great. So now we have our, we took the original shape, reflected it across y, and then we went ahead and subjected that new shape to a 90-degree rotation about the origin.